Rate of reaction. Every day, many chemical reactions occur surrounding us. For example, rusting of iron, ripening of fruits, burning of fuels, etc. Some reactions, such as rusting of iron, take a few days or sometimes even months. The reaction takes place slowly. Such reactions, which take a long time to complete, are known as slow reactions. Now, drop a piece of magnesium ribbon into a test tube containing dilute hydrochloric acid. It reacts immediately to produce bubbles of hydrogen gas. Here, the reaction takes place rapidly. Such reactions, which take a short time to complete, are called fast reactions. Neutralization of acid by an alkali is one such example. For a chemical reaction to occur, the reactant molecules must collide. As only a fraction of molecules have sufficient energy, and the right orientation at the time of collision to break the existing bonds and form new bonds. We will look at these factors in detail. 1. The energy of collision. We all know that coal does not react with oxygen in the air. But on burning, coal reacts with oxygen rapidly. This is because when we light the coal, we supply it with energy. And coal particles get enough energy to react with oxygen molecules in the air. This minimum energy, which is needed by the reactant molecules for a chemical reaction to occur, is called activation energy. When the molecules A, B, and CD collide, their outer electrons make contact. Hence, there is repulsion between the atoms. Energy is required to overcome this repulsion and to break the old bonds. Thus, products AC and BD will be formed. Only if AB and CD possess the energy equal to do more than the activation energy. We will consider this factor of activation energy in reference to exothermic as well as endothermic reactions. Exothermic reaction. The reaction between nitrogen dioxide and carbon monoxide is exothermic. Heat is released during this reaction. The products, nitrogen monoxide and carbon dioxide, that are formed have less energy than that of the reactants. There is an energy barrier between the reactants and the product. If particles NO2 and CO collide with less than the activation energy, they bounce apart and the chemical reaction does not take place. Only those collisions which have energy equal to or greater than the activation energy result in a reaction, and products NO and CO2 are formed. Endothermic reaction. In the case of an endothermic reaction, such as the reaction between nitrogen monoxide and chlorine, energy has to be supplied to complete the reaction, forming products nitrosyl chloride and chlorine. Since energy has to be supplied for the reaction to proceed, it is called endothermic reaction. 2. The orientation of collision. Reaction between ethene and hydrogen chloride. The reaction does not take place when hydrogen chloride approaches ethene molecule from the far left or far right side of a double bond. Will result in molecules bouncing off each other. The reaction takes place only if hydrogen atom of hydrogen chloride approaches the carbon-carbon double bond in this orientation. Hence, chloroethane is formed. Therefore, orientation of molecules during collisions is very important.